All right. So today what we're going to do is we're going to look at now, instead of having just the original derivative, now we're going to have the second derivative. And we're going to try and figure out what is my original function, or it might say what is f of x. Okay, so if they told me my second derivative was 4, that means that if I integrate, right, if that was my second derivative, now looking at my first derivative, that's still going to apply the same rules. Just a constant becomes 4x and then plus c. Then when I go and look over here, I want to use the information that talks about what happens at f prime at 1 equals 6. So now it's saying there's my x value, right? This is my x, and that's my y. So 6 is going to equal 4 times 1 plus c. Whoops. So 6 equals 4 plus c. Subtract away my 4. That's going to tell me that that's c. So I don't have my answer yet, but I'm on the path. Now I know that my first derivative is going to be 4x plus 2. Then from there, now I'm going to go and say, well, if I want my original function, that's going to tell me, well, it's going to be f of x equals, use my power rule. If I add 1 there, that's going to make that 2, and then 4 divided by 2, or 4 times 1/2, that's going to make that 2x squared, and then plus x plus c. And then again, go back and look at, well, now it's talking about what's going on in my original function. Notice there's no tick mark there. So this is my x, and that's my y. So 3 equals 2 times 2 squared plus 2 times 2 plus c. So 3 equals 4, so 8 plus 4 plus c. So 3 equals 12 plus c, which means that that value is going to end up being -9, and go and replace it. There's my original function. If it told me that my second derivative, notice the amount of tick marks there, is 6x, and it goes and says, you know, something that happens on your derivative and on your original. So this is my next step. So if I have my second derivative, if I go and integrate that, that's going to now say, now there's my derivative. Add 1, that makes that squared, then divide by 2, that's going to make that 3x squared plus c. And then plug in the information that you know, and of these two, which one has a tick mark? This one. So this is the x I want to use, and this is the y I want to use. So I'm going to have 3 equals 3 times 2 squared plus c. So 3 equals 3 times 4. So 12 plus c, that means that c is -9. So now I have 3x squared minus 9. Now I want to go and find my original, which says now go and integrate. So now I'm going to have f of x. There's my original function is going to equal. If I go and add 1, that's going to make that x to the third. And if I do 3 times 1/3, that's going to go and make it just x to the third. And then minus 9x, and then plus c. Then use information I know. This is my x, so 1 minus 9 plus c equals 1. If I go and subtract, so -8, so I'm really going to add 8. That's going to say 9 equals c. And get rid of my c. I'm going to go and make that plus 9. So essentially, I'm just doing this twice now because I have my second derivative. If I know my second derivative is 16 over x to the third, that means I really have this, right? Those two are the same. So if I go and get my derivative, that's going to say add 1. That's going to make that to the -2nd. And then multiply by -1/2. So it's going to make that -8 x to the -2nd plus c. And on this one, that's going to be important when I go to find my next one because it's written with the negative exponents. But when I go and evaluate, and again, These are the values I want to evaluate using on this part because that is the part that has the derivative information. This says that on my derivative, when my x value is 2, then my y is 4. So if I go and plug in, I'm going to have 4 equals negative 8 over, instead of having x to the negative second, I'm going to say x squared in the bottom. So 2 squared plus c. So that becomes 4 equals negative 8 over 4. So that's going to end up being negative 2. Add 2. That's going to tell me that c is 6. So on this one, when I go and take it back up a notch, I'm going to go back and use this c. Okay? So like when we did these and found the second derivative, if it was just sort of on the way, I left it with the negative. And I have the plus 6. So when I go and integrate, now I have f of x equals, if I go and add 1, that makes that negative 1, multiplied by the reciprocal, that just makes that 8, and then plus 6x plus c. And on this one, right, if I go and replace what I know this is 5. That x is really on the bottom, right? That's what that means. So I'm going to have 8 over 1, or just 8, plus, replace that with 1, 6, plus c. So 5 equals 14 plus c. That's going to make that negative 9. So f of x equals 8 over x. When I go and write that, I do want to get rid of my negative exponents. And then plus 6x. And then we said that c was negative 9, so minus 9. And that is my original function. If it said that it also wanted to know what the derivative was, I would want it to look like that. Okay. If I had some radicals. So if I had some radicals, and again, I know that this is my second derivative because there are 2 tick marks. Okay, you might also see the second derivative with respect to y over dx, and that was taken with respect to x twice. You might see that. You could see this. But again, this just means that I really have 2 and then x to the negative 1/2, right? So when I integrate, that brings that up to f prime of x, which is going to match up with this information because it has the prime there. Then if I add 1, that's going to make that to the 1/2. If I multiply by the reciprocal, it says multiply by 2. Well, there's already a 2 there, so 2 times 2 makes that 4, and then plus c. Plug in what I know. I know that my y value is 2, and then I have 4 times 4 to the 1/2 plus c. Square root of 4 is just 2. So 2 times 4 would be 8. Subtract my 8. That's going to make that minus 6. So my derivative there is going to be 4x to the 1/2 minus 6. Then if I take that up a notch, now I'm looking at what's my original function. F of x would equal, add 1, so that's going to be 3/2, multiply by the reciprocal, so that is going to end up being 2 over 3 times the 4 that's already there, minus 6x plus c. So that's going to become 8 over 3 x to the 3/2 minus 6x plus c equals f of x. And then plug in what I know. Thank goodness I was nice for a change. And I know that my x value is 0. So this just becomes 0, right? Minus 6 times 0. So all of that is just saying c equals whatever that value is, which is 3. So my original function would be that right there. And the last one we're going to look at today is if I told you that the second derivative was 36x squared, And I also know this information over here. So again, find out what my derivative is, which tells me add 1 up there, multiply by the reciprocal. So 36 times 1/3 is 12, and then plus c. Then plug in what I know. I know that my x value, whoops, that is not right. That needs to be like that. So I know I want the one that has the 1 tick mark. So if I go and place 2 there, and I have 12 times 1, that's going to tell me, well, c is -10. So there is my derivative. And then if I take that up to get my original function, that's going to say add 1, so x to the 4th. If I go and divide, 12 divided by 4 or 12 times 1/4, same thing. That's going to get me to 3x to the 4th minus 10x plus c. And then plug in what I know. I know that my x value is 1, so I just get 3 minus 10 plus c equals my y of 5. So -7 plus c on that side. If I go and add 7 on the other side, that's going to say 12 equals c. So my original function, f of x equals 3x to the 4th minus 10x plus 12. Okay, so again, this is very, very similar to what we did the previous day, because all we're doing is once I do it once, I do it one more time. And again, it connects back to what we did last week when we were dealing with just finding the antiderivative. Okay, except those were just general solutions. Now we're finding the particular solution. We're figuring out what is that c value. Also, before I let you go, one more great math pun. I see integrals. How often? All the time. That was my best Sixth Sense impression. I hope you enjoyed it. Obviously, I'm not Bruce Willis. But I hope that you're having a great day. If you can find some other great integral jokes, you know, send them my way. I'd love to insert them into videos. I'll give you credit for them. Like, I'd throw your name out in the video if that is helpful. I just hope you guys are doing all right. Miss you. Whether you're watching this in the night, in the morning, you can't sleep, but you know that my notes will put you to sleep, Kobe. I hope you enjoy. Have a good one. Bye, guys.